Alright, so in this video, I want to talk about SEMS codes and analyzer shacks. So this relates to environmental monitoring in our, this is a presentation in our Process Analyzers 2 course at the Red Deer College. So the first thing related to this is we need to talk about the environment, and what the environment essentially is basically everything that humans are exposed to. So in this case, environment is going to be the planet Earth. And the next item that we need to talk about is what a pollutant is, and there's two types of pollutants. There's natural pollutants and there's anthropogenic pollutants. So these pollutants can be in the form of polluting land or water or air, and that's what we're going to focus mostly on in this presentation is air, because the analyzers that we talk about in Analyzers 2, that's what they're primarily focused around, is measuring gas samples. So, an example of a natural pollutant would be like the decomposition of life. Or volcanic. These are going to be just naturally occurring, right? Something decays, it can give off a pollutant, a gas pollutant, and when volcanoes erupt, they can give off lots of pollutants into the air as well. The other term, anthropogenic, is a pollutant that's added by humans, so by human activity or an industrial facility, right? That's pumping pollutants into the air. Another term that relates to pollutants, or a pollutant, is accumulation. And when accumulation, it's defined by two things: the emission rate, so how fast these pollutants are being emitted, flow rate of how much these pollutants can be or are emitted into the atmosphere or to the environment, and dispersal speed, so how quickly they disperse. If there's a lot of wind, it'll help to disperse them and they won't be highly concentrated in the environment. And another key term that relates to that accumulation is temperature inversion. And so a temperature inversion is when we have cool air at ground level and hot air above. What that'll cause to happen is the pollutants, when they come out of the stack or wherever they're coming from, they'll want to collect at ground level, and that's a problem, obviously, for humans and animals and stuff that are on the ground, because they're going to be exposed to these higher concentrations of the pollutants. And that's going to increase the accumulation. So during normal operation, or when we don't have this temperature inversion occurring, when cool air isn't on the ground, the sun's going to heat up the ground, and the ground's going to heat up the air at ground level, and the hot air is going to rise and carry the pollutants away. And that's what we would rather see, rather than having this accumulation at ground level. So the next thing that we need to talk about there, after we kind of discussed all that initial stuff, is the air quality measurement. There's two terms that we're going to discuss around air quality measurement. There's the first one, continuous emissions monitoring, and that's basically how we monitor for these pollutants. Continuous emissions monitoring is when we do it right at the source, when we have our analyzer right at the stack, and we're taking a sample, whether it be the analyzer's right in the stack, or it's separate and it's pulling a sample out and running it through the analyzer. These types of analyzers that are used for continuous emissions monitoring are going to be monitoring in concentrations of ppm or up to percentage. So this is actually considered a higher concentration than the other type of monitoring that we're going to talk about. And what that's called is ambient air monitoring, just monitoring the ambient air rather than monitoring directly at the source of the pollutant. And so in Alberta, in the province of Alberta, we have these ambient air monitoring stations in specified locations throughout the province. So specified locations strategically placed throughout the province, and they require sensitive analyzers down to the parts per billion range, because we're dealing with concentrations that are a lot lower. We're not right at the source now. So that's we need analyzers with high sensitivity for ambient air monitoring. The SEMS code, which stands for Continuous Emissions Monitoring System, this code is it outlines the requirements for install for analyzers that are doing continuous emissions monitoring right at the source, operation, maintenance, and certification of these. So how that all plays out, this code is going to specify that. It also specifies how to monitor for the pollutants at the stack, and the ones that are specified in the code are going to be SO2, nitric oxide, nitrogen dioxide, NOx, which stands for total nitrogen oxides, or basically the combination of nitric and NO2, or NO and NO2, sorry. It also specifies monitoring for carbon monoxide, which is CO, TRS, which is total reduced sulfur or sulfides, and this is going to include H2S, so pollutants that have a sulfur atom in them, particulate matter, which is PM, and carbon dioxide. So all of, I just see here, I'm just going to point this out, it should be a TS here instead of ST at the end, pollutants. So all of these pollutants, for monitoring for these pollutants, it specifies in this code how the analyzers should be set up, the analyzers that are used for monitoring for these pollutants. And now, kind of diving into the continuous emissions monitoring terms a little more, there's a form of measurement which is called in situ, where we install the analyzer basically directly on the stack or in the stack, and we don't have to pull a sample through a sampling system, so it's kind of a benefit there. So it's installed directly in the stack. It's ideal, but one problem usually being that you have to service these instruments, and if they're way up on a stack, it makes it trickier than one that is in a warm shack somewhere. And that's what extractive is when the analyzer, it's going to be separate. It's not installed right on the stack. So if we analyze the sample that is removed from the stack, and it's pulled away through like a pump, and it's sucked in to the analyzer, and then it outputs a reading. So for extractive, that's the one we're going to focus on. Is there's two methods. There's the hot wet method. Or sorry, there's the two. We'll talk. Maybe there's three. We'll find out, I guess. There's the hot wet method, which the sample's going to be dirty. It needs to be heated, and we're going to have water vapor, because when we have combustion, which most of these industrial processes, that's what we're going to be discharging as the exhaust from something burning, we're going to have a lot of H2O in them. So we need to heat the sensing line. That's what that red squiggle around the line is we're heating it, keeping it warm so the water doesn't drop out. And then if we weren't heating it, the water could also cause the lines to freeze and plug things off. So the samples that we're dealing with the hot wet method is going to be that we're keeping it warm. It's a full sample. It's dirty. Needs to be kept warm and heated. The cool dry method, when we're using extractive analyzers, we're extracting the sample. We run it through a sample conditioning unit, and the sample conditioning unit, the SCU, is going to get rid of the water, and now we don't have to heat the line. The thing is, now when we report this, the wet fraction that we're dealing with here in this is used for the hot wet method. It's going to still have the H2O in it, and this is basically going to be the sample as it is from the stack, right out of the stack. But down here, in the dry method, when we're using our dry fraction here, the concentration is going to change, because now we've removed this water down here. It's gone, and what it does is it makes a higher concentration of X, the sample that we're trying to measure, right? And so that needs to be considered. It needs to be known. So when we're measuring these pollutants, we need to indicate what method we're using. So that's what this here is. We need to state the measurements, if it's a wet measurement at 100 ppm or a dry measurement at 100 ppm, because that's going to indicate when we're with the dry measurement, the one in the stack's actually going to be a lower concentration, right? Because we this one here is actually a higher concentration, which means in the stack it was a lower concentration because we removed the water. The third method, so yes, there's more than two. The third method is dilution, and what we do here is we dilute the sample with clean air, and so that's what's happening over here, is we're diluting it with this clean air, and we need to know the ratio that we're diluting it to. So I gave one of 100 to 1. We dilute it, it comes into the stack over here, and then it gets diluted with the air. So the yellow now is that diluted signal. If the analyzer measures 1 ppm over here, we need to multiply that by 100 because we're diluting it by 100, and then we can state the concentration in the stack. And so the benefit here now is the water vapor isn't being removed. There's just a lot less flowing through the line because it's been diluted, and we don't have to worry about it freezing off or condensing out now. And so this here can be reported as wet. Once we multiply it by that factor. Whereas in the dry method over there, we had to indicate that it was dry, because that's going to tell us that the concentration is actually higher, and we'd have to apply a factor, which is this dry factor right here. We'd have to apply a factor to the measurement to get the correct value in the stack. So hopefully that all makes sense there. So now, moving on to ambient air monitoring, where we have the lower concentrations and the stations the analyzers strategically placed throughout the province. We have 160 stations in Alberta. 100 of those are actually ran by industry. The other 60 or so, I think I looked on the website, there's actually a few more now. I think there's like 70 or something like that, are ran strictly by the government. And so these monitor pollutants and wind. So in these stations, they have analyzers for different pollutants, and they also measure the wind speed and direction. And so the reason for that, you can see here, the wind direction, it's going to indicate the location of where that pollutant's coming from. So we can then narrow down, the government can say, oh, hey, someone's putting a lot of pollutants in the air all of a sudden. We got to go find out who's doing it and why, and that wind direction is going to tell us that. Wind speed also indicates dilution. So if it's high wind speed and stuff like that, that means that it's probably being diluted, and the concentration's actually higher than what it would be if it wasn't, the wind wasn't so high. The wind speed wasn't so high. In the pollutants, there's a lot more pollutants that fall under the ambient air monitoring code. You can see we have ammonia here, carbon dioxide, carbon monoxide, methane, total hydrocarbon. So that's going to be like probably like some of your gases like propane and stuff like that in the air, and H2S, which is toxic, total reduced sulfur, which H2S would fall under, but also there's other compounds. Total reduced sulfur, usually a major source of that is going to be pulp mills. The craft process in pulp mills gives off a lot of sulfur. If you've ever been to Hinton or some of those towns that have pulp mills, you can smell that, relate to that smell from total reduced sulfurs. NOx, NO, and NO2, these are all produced from automobiles, heat, and air. That air is made up of nitrogen, oxygen, heat, a lot of heat from a combustion engine or processes that have high heat are going to take that air and cause it to form these pollutants here. And we're going to talk a little bit more what the problem is with those pollutants later on in this video. O3, which is ozone, ground level ozone. We don't want that. It's bad. It's highly reactive. It's damaging. We don't want to breathe that in. Particulate matter is just going to be, we're going to talk a little bit more about that as well right away here. And then our SO2, which is sulfur dioxide, it's another major pollutant from burning coal. And TSP is total suspended particles. So that's going to relate back here to the PM, particulate matter. And then VOC is volatile organic carbons, I believe, and that's going to be stuff that vapors from hydrocarbons like gasoline and stuff like that. So whereas the total hydrocarbon up here is going to include things that are normally gases at ambient pressure and temperature as well. So whole whack there. I don't expect you to memorize those or anything like that. Just showing you that there's a lot more that they monitor at these ambient air stacks or ambient air monitoring stations that are placed throughout the province. So particulate matter, I want to talk a little bit more about the particulate matter, just to break that down. So there's three categories of it. There's the TSP that we mentioned up above, and that's going to be anything that's less than 100 micrometers in diameter. So dust particles that are less than that would fall in that category. The next category is PM10, which is particulate matter 10, and the 10 stands for 10 micrometers right here. And those things will get caught up and stuck in the nose and throat of humans because they're a little bit bigger. But the smaller ones yet, which are PM 2.5 right here, which is 2.5, and there should be a micrometers written here. That's the size. They're a lot smaller particle, the third class here, and they will get right down into the lungs and cause damage to the lung tissue. So that's why we monitor for these at these monitoring stations, to see how much that's in the air, because we breathe that ambient air in, and we want to know if it's hazardous to us, right? So things like forest fires and stuff like that are going to really drive this up, the particulate matter. And so now, to kind of speak to all those pollutants, we talked a little bit about them, but we want to talk a little bit more about the problems and why we monitor for those, just to give a reason for all of this. And so air quality affects our hearts and lungs, and the three measurements that they make to, I don't know if you pay attention to the weather or anything like that, they'll give out an air quality health index, and that's what this is, AQHA. It measures the amount of ground level ozone, PM 2.5, and our nitrogen dioxide in the air, and that's going to give us an air quality health index. And what that does is it basically tells us if it's safe to breathe the air. So those are the three pollutants that they monitor to determine that. And it's on a scale from 1 to 10. So if you check your weather apps or weather, it'll usually have a air quality health index stated somewhere. Acid rain is another problem, not so much anymore. It used to be a lot worse at some of these industrial facilities, but SO2 and NOx, both of these, when they mix with water vapor, which is a major component for combustion, when we're burning like coal and stuff like that, you'll have SO2 plus you'll have the water vapor. And when they mix water vapor and SO2, it forms H2SO4, which is sulfuric acid. And so that sulfuric acid, it causes acid rain and damages vegetation and is bad because it's acidic. The other acid is HNO2, which is produced with the the oxides of nitrogen, and it'll also form acid rain as well. The other problem is climate change, and the ones that contribute to that is CO2, H2O, and methane. Methane is supposed to be one of the worst ones for that. It absorbs the most IR, or infrared light, from the sun. And so in these gases here, they absorb the IR. The IR comes in and hits them, and they absorb them, and they start moving around more and basically create more heat energy. And it heats up the earth, and so that changes our climates. So they also want to monitor for how much of that we're putting into the air. The ozone layer is another one, and it, in recent time, I've heard it can recover. It's one of the things that can recover, and what's happening is the ozone layers are going up, which is good. Ozone layer is fine. It's good for us when it's at a high elevation, way up above, but when it's on ground level, it's not so good. We don't want to breathe ozone in. It's really reactive and bad for our lungs. But at a high level, it protects the atmosphere from UV light. UV light, which is damaging, it contains a high amount of energy, gives us a sunburn. The ozone layer, ozone is reactive, and it reacts with these CFCs, which is a chlorofluorocarbon, which is it's a mouthful, but basically those are from, the major source is from your refrigerator. It has refrigerants in them, and these refrigerants contain these CFCs because they're great for when you compress them and then expand them, they create a cooling effect, and they're really good at that. But the downfall is if you put them into the atmosphere, they react with ozone and eat it up in a hurry. So now that they've implemented programs where you have to properly dispose of refrigerators and stuff like that and not just vent the gas into the air, the ozone layer has recovered quite a bit from what I've heard. And another thing just to relate to ozone smells is that electricity smell that you smell. If you've ever been around, like, I don't know, an electric train or something like that, it kind of has the smell of electricity. And if you've smelled that smell of arcing and sparking, when you have an arc and a spark, it takes the ozone, the oxygen in the air, and what it does is it creates ozone. And ozone usually doesn't last for very long because it reacts with something quickly because it's looking to react. It's fairly unstable, so that's something that you can maybe relate to in everyday life where you maybe experienced ozone. So now that we've kind of talked about all these pollutants, some general terms on how they're monitored, the last little bit is on the government roles here. So there's the federal level, provincial level, and municipal level, and we'll talk federal and provincial here. So the federal level, we have Environment Canada, the National Energy Board, NEB as it's often called, and Canadian Environment Assessment Agency. So Environment Canada, their roles are to protect the environment, conserve national heritage, which in this case we're not really too concerned about, and they provide wet weather. But the big one here is that they protect the environment at the federal level. The national, or the NEB, the National Energy Board, regulates international and interprovincial oil and gas and electrical transmission. So any project that's international or interprovincial, they're going to be handling it, making sure that it's done properly, and that whoever is implementing the project or doing the project, that they're doing it properly to the guidelines at the federal level for Canada. The last body here is the Canadian Environment Assessment Agency, and they basically work with the NEB, and they perform actual assessments and stuff on companies to make sure that they're doing things properly. So these three, Environment Canada is an actual department of the federal government. National Energy Board has private people from both public and private sector sitting on that committee. And same with the Canadian Environment Assessment Agency. These two on the right are kind of independent agencies that work for the government. Still under the government roles, we have at the provincial level here in Alberta, the main one that we're going to talk about. There's the Alberta Energy Regulator, and it kind of overlaps with the roles of the Environmental Sustainable Resource Development Department of the provincial government. And what the ESRD does is how we can remember it for acronym. ESRD is they regulate that air quality. They regulate surface water quality. They also regulate land, or help prevent contamination to the land. So they regulate all that at the provincial level, and not so much as the whole country, but now we're dealing with each individual province, because each province has their own industry, so they kind of hand that responsibility down to the provinces. And the one that we're focusing on in this presentation is all around this air quality right here. So that's where the air quality stuff falls under what department takes care of it at the provincial level here in Alberta. And for industry to do anything, basically, any of their projects, like a new construction of, say, an oil and gas facility, or maybe an upgrade to a pulp and paper mill or something like that, anything that involves an industrial process that's going to be producing pollutants, they must get approval from the ESRD to construct, operate, or upgrade those facilities. So, pretty important to know is to know all this information, because if you do get out there in industry and you are working with analyzers that monitor for these pollutants, it's kind of important to know why we do it, and the different government departments that are involved with it, some of the terms. I don't expect, obviously, to be an expert coming out of this course, but having those discussions, seeing these terms and kind of seeing where they come from, it's really important, because when you do work with analyzers, you end up quite often specializing, but if you've seen these terms before, it can kind of really help you, and seeing that high-level overview of why we do these things and why we monitor for these things gives you a better understanding and kind of a purpose to servicing and working on those analyzers. So hopefully this presentation kind of summarized that. I think we had like 70 slides on it, so I wanted to quickly summarize it and kind of tie things together and give an overview. Didn't go into all the individual details of the presentation, but hopefully this helps summarize it for you.